Hey everybody, this is Larry. This is me going with contest 269 Q4. Find all people with secret. Um, so the secret the secret to this problem is you have to hit the like button and the subscribe button. Join me on Discord where people talk about this contest and this problem and just share stuff. Come hang out. I prefer. I know if you don't know what Discord is, it's like a link somewhere. Uh, there are a lot of places to link. But yeah, just come hang out. Um, anyway, so for this one, it is just it is a simulation problem, right? And what is a simulation problem? Simulation is just follow the rules that they tell you, and do it in a way that is, yeah. But the tricky part about this problem with respect to the simulation is that there are a lot of different things you have to consider, and if you don't implement it correctly in a good complexity, if you don't do it correctly and if you don't do it in a good complexity, you may just get it. It may take too long, right? Because n is 10 to the fifth, and they're 10 to the fifth edges. So yeah, so the first thought, so anyway, I am explaining these live, but for this channel, just to kind of as a disclaimer earlier on, because I think sometimes I get this question, but just as a disclaimer, I am explaining my thought process during the contest, just to kind of show you what my thought process is. Hopefully maybe you learn from my mistakes, or maybe not. Maybe you find interesting, if not, just watch it on a faster speed or fast forward a little bit. Because for me, not that I don't like it, it's just that what I want to do differently from other people's videos is that, there are always people trying to show you how perfect they are in their code and their explanation, and everything is well prepared and so forth, and that's fine if that's what you're looking for. For me, I want to show that even someone who is maybe I would say maybe arrogantly, you might disagree, but arrogantly, I'm relatively good at these things, and I still kind of make these kind of mistakes and these kind of errors, and how I try to figure out how to learn for it, for next time and so forth, right? As you can see, I spent out actually 30 minutes with two wrong answer, but yeah, so this is a little bit of a mess for me, relatively, right? But these are this is why I want to take the time to kind of explain it a little bit in depth, because it's harder to learn when you get things right. There's still opportunities to learn even when you do things well. Just that is sometimes a little bit trickier, and you should celebrate victories anyway, by the way. So anytime you get to celebrate victories, you should do it. That's the secret, maybe. You don't really get that many victories in life in general, so celebrate all of them that you can, and don't let little things tie you down. But anyway, what was I saying? But yeah, so I struggle with this one. So one thing that happens sometimes, and if you practice a lot, you kind of, think about a problem, and you're like, oh, this is similar to another problem that I did, right? And for me, I think for this problem, I was thinking about maybe similar-ish problems where you have these connected, and you have components, and you're trying to connect them at a certain time and so forth, right? I think the nuance about this, and if that was the case, I think there was another another Q4 maybe a month ago or something like that, where you basically have these components that start out separately, and then at a certain time you merge them together, and that's fine, that's okay. But and that problem sounds very similar to this problem, and that's where my mind went first. But sometimes you have to think about the nuances. Sometimes you have to think about the minor differences. Sometimes you can change very minor details, and the problem becomes very different, right? And this is the case. The case is that you only care about people with a secret, right? But that said, you can watch how I approach and attack this problem live during the contest, but I did end up implementing union find, and I tried to figure out, I kind of implemented union find and then hacked the secret part on top. So that wasn't very fundamentally sound. I was getting wrong answers, as you see the wrong answer, and you can watch it on the contest live video next. But I was definitely getting wrong answers, and it was very sad. So then the one observations that I did make was that I did not need union find, because you're trying to tell everyone the secret anyway. So I actually end up rewriting this to not have union find, but I would still have a wrong answer. So let me actually go over my wrong solutions first, and then we'll go over my right solutions, right? But the concept behind this problem is simulation. So I'm going to emphasize the explaining the implementation and the data structure part of it a little bit, and the analysis of it, because the analysis of it I was doing live during the contest to make sure it's fast enough. Otherwise, everything is actually very simulation-y, and that's it. For the most part, I mean, at least if you're wanting to get Q4, I don't think the other parts are that much more difficult. But yeah, let me actually, which one is this? Let me open both of them then. So the idea that I had, I'm going over the wrong solutions. I don't know if like I said, if this is not interesting to you, fast forward a little bit, or just watch someone else's video if you really feel like all you want is the answer. But this is my thought process. So I did actually end up with this long code where, okay, and you may, this is a common thing that comes up sometimes, is that, and if you're a follower and a watcher of my videos, you know that I love to do sweep line defense type things, and for this particular problem, that's how I structured it. Okay, so actually that wasn't the wrong answer. I have to click on the wrong answer instead of the problem. Sorry, friends. But this is my wrong answer. So basically the idea is that I have this sweep line thing, I append it so that they all happen at the same time. And then I have this, so I have two components, right? One is that, okay, I sort by the time, this part makes sense. And then the second one was that I have this greedy algorithm of, okay, so I have all these events. I wanted to sort by the number of people who have heard it first, so that if hearing it has a component, we want to do the hearing first. So basically that's yeah. And then I go, if person A heard it, then I would put it on the front of the queue in the order to process it. So we process it in the order of number of people who heard it, right? Unfortunately, this is wrong, but I actually used union find, which is unnecessary. I in the process of debugging. So one thing I would say is that when I was debugging this, I did get a hidden input wrong answer. So that took a long time, because I am also, to be frank, a little bit out of practice with hidden inputs, because I think I just wasn't, I had to come up with a long time to come up with a solution in which my code was wrong, and then implementing it was easier after that. But yeah, I'll explain what I mean in a second. So actually, after doing this, I realized, okay, actually the union find was not necessary. So let me just get rid of the union find. So this is mostly the same code in 20 lines of code, but without the union find, right? But basically, if person A or person B has heard it, then we set both to hearing it. But the key part is this greedy, where we sort so if there are multiple meetings that happened at the same time, we sort it in a way such that, the more people heard it, then the better. However, this is still wrong, and it makes me very sad. It took me 14 minutes to go from here to the right answer. So I deserve how poorly this particular one is. But yeah. So what is wrong here? So the wrong part was the greedy part. I think most of this is right, except for this greedy part. And what I mean is that there is what I didn't consider. So I don't know. I think I was just trying to solve this as quickly as possible. I saw a lot of people solved it. And I rushed it a little bit without really thinking about the nuances. And the thing about this particular thing is that the greedy part is wrong, meaning that, okay, so let's say I have a lot of pairings, right? And I sort them by, okay, two people in this list, have heard it, so let's put them in the front, and one person on this list have heard it, put them near the front, and so forth, right? My logic here, in a greedy way, my intuition, which usually is right, as you can see, maybe, but it was wrong in this case, was that, okay, in this case, if you've heard it, then you want to be in the beginning of the queue. But this is apparently wrong, because there is a scenario in which in the beginning, so the problem with this is that it's static, right? We start at the beginning of this. So if one person have heard it, and they may spread it to a pair that is, so you may do it in an order in which, for example, because basically we process these events, if you think about it as a list from left to right, but there may be a situation where, because we sort it in a particular way, it can go from index I, like in terms of edges, you can, A tells B, and then B tells C later on, and then C tells D earlier on, but we processed it in the wrong order, right? And I guess another example is that if both people, if you have two events where no one has heard it, that order could be wrong, and that's basically what happened for me, is that yeah, I didn't think about this case deeply enough, to be frank, and that was wrong. So after submitting this, even though I cleaned up the union find wasn't necessary. The reason I did union find, because when you looked at these problems, the first thing that I see is connected components, and union find is generally a very natural extension of that. So this is wrong, because if neither person have heard it, if there's two groups of events where neither person have heard it, the order matters, but I might have it in the wrong order, right? So that's basically the idea. And then I'm gonna go over the right solution about 12 minutes in. So I hope you stayed along for here. So the right idea here is, it's still incremental from what I had before. A lot of this will look similar for this, but what I end up doing is that I do a breadth first search, which is of course very connected component E, but we try to do it in a very deliberate way so that we don't waste extra cycles. So the thing that everything you can look at is a hash table, because if you have an array of, for example, visited is set, right? If we have row visited is equal to force times n, which is a very natural way of writing before breadth first search, then this loop times this thing is going to be expensive. So everything has to be using set. I wrote this in a funky way, but yeah, well, let's actually write this here. But yeah, so basically for every event, I'll go over in the order that makes sense. One thing that I also do is that I just, for the first person, I just add it as a event. I keep track of all the people that have heard it and set the initial condition. And then I set up the events. I put it in the meetings thing, and then I sort the time by time, and so for every time, and this is sorted, that's fine. For every component, I look at all the things that we care about, right? So care is basically all the indexes of all the people that we care about. Again, we do make sure. So the reason why I have this care is because I did not want to do a linear type thing. I want to keep it, or we want to be linear in the size of the number of current edges, and not the entire this end, right? We don't want to be, so then this is basically me creating an edge list. I guess I have to do this. Whoops. So this is me creating an edge list of all the events that are happening at this time instance, and we mark that we care about these indexes. And then here we just go, okay, for every person that we care about, which is the people who are in this current time frame, for every person there, we see, okay, if we have not visited, and if we heard if this person has the secret, then we visit it, and then we do a breadth first search. So the reason why I wrote it this way here is because I actually had this with a depth first search, but I worried that we're going to get like a what's it called, depth, max depth, or max recursion limited something, or stack overflow or whatever, stack limited reach or whatever it's called in Python. So then I rewrote this using BFS, which also took a couple of minutes, but it's fine, it's right. So this is just standard BFS, which is my BFF, I guess. BFF, BTF, yeah. And this is straightforward, right? Or this is straightforward if you are from a BFS. If you're weak on BFS, please go do another problem. This is obviously, for me, a prereq, though you can do this another way. For example, you can actually do this in Union Find as well, but I thought that a BFS would be more straightforward to understand. So yeah, you can do it with Union Find. But you have to also be really careful to make it a set version of the Union Find and not, an array version of the Union Find in the underlying implementation. But yeah, but this is just BFS, so we put the item U in here, and this is just connected components BFS, right? We just visit all his neighbors, and then we mark them as visit, and we also tell them the secret, and then we put them on the queue so that they could tell their friends the secret, right? And that's pretty much it. And then at the very end, we check to see all the people who have heard the secret. If they heard the secret, return the answer. So then the question is, why is this fast enough? If we have, naively you can say, oops, this has O of Y for number of events, and here this can have, this can be O of N, right? But the reason why this isn't the case, and of course there's a sorting here, but we'll get to that in a second. But the reason why this is not O of N times Y is because it gets dominated by the Y, right? That means that for every edge, the sum of all these things is going to be O of Y, because in an amortized kind of way, meaning that I don't really have a great explanation about this, but you can think about it as, okay, if all the edges are happening in one time slot, then what happens, right? If all the edges are in one time slot, then this complexity is going to be linear because then care would have n items, say, and then, but this will only have one, right? We only have one iteration of n items, and this is O of n because this is just breadth first search. So yeah, if all the events are in one time slot, this is O of n because of what we said, because of all the care. If all the events are in different time slots, then this thing is going to be O of Y, maybe technically they're O of Y iterations, but because of that, this is just going to have two items, right? So that means that this is this plus 2, so this is going to be O of Y. Of course, there's the sorting of the keys, so this is going to be actually O of log Y. So yeah. So then you could say that the complexity is O of N times O of Y log Y, roughly speaking. Yeah. And in terms of space, we have O of N space, not N actually, O of N plus Y space, because for every event we only put it in current edge once, and also care and visited once for every event, so it's going to be O of N this space. Cool. That's all I have for this one. Let me know what you think. You can watch me solve it live next. Hopefully this was way and I didn't really think through the edge cases, and that's what sometimes it gets you, is that this happens to me. This exact bug happens to me a couple of times. I need to be better about it, to be frank. But yeah, let me know what you think, and you can watch me solve it live next. I'm already got it finished, so I'm a little bit slow, but that's okay. Person is a 0. Okay. Person 0. It's gonna be union fine. 2 at time 5. Oh, 0 is a person and first person is okay. This is pretty straightforward. I just need to type it. Okay. Oh, actually, maybe not. Because I would have union 1 and 2. But none of them know. That's fine, actually. Let's see. Maybe still union fine, but only if one of the people know, then it spreads. Yeah, okay. Still. Maybe. Yeah, okay. I don't think it's that hard, so maybe. I don't know if that's true. We'll see. Okay. This is a little bit annoying. Still gonna be union fine, but sorting every time. Okay. Take it slowly. Okay, just work on it. Okay. Not that many meetings. You can sort it every time if you like. Yeah, okay. this is the case that I was thinking about. I should be able to get this. It's not impossible, but it is a little bit potentially sloppy. Doesn't really matter. Oh, I guess. Hopefully this is fast enough. 10 to the 5th should be okay, but maybe, I don't know. Care about the edges. Maybe I can do this in a different way. Okay, let's actually do the union file. Path compression may be a little bit messy. So this is who. Kind of. What we want is actually I don't know if this is enough. introduction. Where? Oh, whoops. I'm missing some, am I? Nope. Well, definitely missing some on the other ones, right? Okay, let's see. Why am I missing some? Three shares of 4. Okay, so I think I'm doing a little bit wrong there. Why is that case wrong? Okay, at times 0, 2, and 3. Did I mess up the sorting? Oh, whoops. This should be. That's dumb. Okay. Now I don't know if it's gonna be fast enough, so hopefully this is fast enough. 1, 2, 3, 4, 1, 2, 3, 4. Let's go. Oof. Oh, get a wrong answer, huh? That is not what I expected. A lot of people got this already. Oh, wow. A lot of people got this already. I really should have this. Am I missing a more obvious answer? Well, maybe I think the union one is a little bit weird. For sure. Wish there was a. This is the only part that I find sketchy. Well, maybe this as well, actually. graph compression. It's always a little bit hard. Maybe I could have done something smaller. It took so long to do it the wrong way. This is a little bit sad. I guess I didn't really need this. Let's see. Maybe I didn't need union find. I was just being silly. Yeah, I was just being silly actually. I think I just made it more harder than it needs to be. Huh, still a wrong answer, huh? Did I mess up? Where am I getting a wrong answer from? This is gonna be a big tank. But I don't think this is hard, but I'm a little confused where the wrong answer could be coming from. This is, I guess this is greedy, but did I mess up anything weird? Why? This first person thing is also just weird, but that's besides the point. I don't get it. What a disaster. Even if I get it now, I have a 10-minute penalty, but why am I wrong? What am I getting it wrong for? Is something silly? Yeah, okay, that looks good. I don't get it. Why am I wrong? Tell me why. Am I missing one? I do have to input. I don't know. I'm stuck on this one. Yikes. Huh. There's really nothing that tricky about this. What? I mean, it's probably a big case anyway, but still. I really don't know. A lot of people got this. I don't get it. Am I missing some part of this? I don't know. Oh, I see. Because this can change. I see. Okay, this is actually wrong. Okay. Then how do I do this? How do I fix this? Oh, I see. Okay, I am dumb actually. Okay, that's a good one. Hmm. Think about this. How do I do it in a way that makes sense? Do I do unify on this part? Yikes. Okay, I know that why I'm wrong now at least, but shouldn't have written two cases for it. Two wrong and one wrong. Okay. How do I do it? A queue may still be too slow. Okay, I know how to do it. Okay, I know how to do it. Okay. Yikes. Okay, and then that's going to be linear. Okay, so that's good. Okay. Oh man. Wow. Okay. I got this, Larry. You got this, Larry. Keep going. Cool. I guess I do have a lot of recursion. Well, this is just actually mobile, but may run into a recursion issue though. Okay, that was a silly mistake, actually. Yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Anyways, stay good, stay healthy, to good mental health, and take care. Bye bye.